Welcome back to another sunny day in Thailand, and I'm going to walk you through some of the parts and supplies I've been collecting for upcoming aspects of the motorbike project, focusing primarily on the new battery pack.
What parts? What parts?
Different parts.
Parts is parts.
So there are three levels of suppliers that I can get to based on distance and convenience and the supplies that I need. The first is my local town. I've got one little electronics lady who has a tiny little shop. It's a miracle if she's got anything I need, but I always try to go to her first. I've got a decent sized hardware storage kind of place, which is good for nuts and bolts and screws and wire and bin boxes and things. After that, I've got to go to Bangkok. There's a really lovely neighborhood called Ban Mo, Banmo, and it's a little rabbit warren full of electronic shops with everything you can imagine, almost everything you can imagine, from like 1,000 capacitors to wire to there's a lady who does nothing but little microcontroller boards. There's LED shops. Great stuff. Anything I can't find there, I've got to go mail order from China. So I try and do my searching for parts based on that order. It's good to be able to see something and hold it and look at it and make sure it does the job for you. But if it doesn't, then I've got to go to China. And that's not immediate gratification because even though I'm only a couple of countries away from China, it takes two's not even right, 3 weeks for most of the parts to get to me. So I've really got to plan ahead on a lot of my parts gathering. So let's take a look at some of the parts I picked up on my last trip to Bangkok. First one is Shrinkwrap. I got a multitude of different diameters of Shrinkwrap, just because it's always good to have on hand for different sizes of wires. I'm going to be dealing with very thin wires in the battery pack and thicker wires. And it's just good to have that kind of insulation going. And then this one is good, especially this super thin. I'm thinking this would make good wire identification sleeving. So if I can take a very fine pen and then write the function of the wire on this, cut it off, slide it over the wire, and then heat gun it down, that identifies the wire for me. So if I've got 10, 15 wires coming out of the motor in the back of the motorbike, with the Hall effect sensors are tiny wires, and I don't want to mislabel them and hook them up the wrong way. So I've got plenty of supplies on hand for different amounts of shrink wrap. The next thing I was stocking up on are bus bars. You might remember these from before. I used them in another part of the project, but this time I went for bigger bus bars with more connections, and they have a small size and a large size. And this puppy has a lot of connections and can carry a lot of current. Now, the battery pack I'm envisioning has 16 battery modules inside, and each one is going to have 20 batteries. So each module is kind of a battery pack on its own. And then they'll all be wired up in parallel. So I need 16 connections here, plus an out to the motor controller and the charger. So I'm going to have to even double up on some of these connections, but it shouldn't be too bad. And I'll 3D print a new holder for this, for the negative terminals and the positive terminals, and mount them inside the pack case somehow. But this is exactly what I need for this scenario. And this one shop in Bangkok is the only place in the country that I've found, or even online, that has anything like this. I mean, if I had a piece of bar stock and a tap and die set, I could make it myself, but you'd think the world would need things like this. I just don't understand. Next up are the special pins for the motor controller. Now this is the one that came with the controller, a male and a female, and as you can see, the opening is rectangular and the pin itself is a flat rectangle, and it fits in like that. Of course, I couldn't find anything locally, so I went to a number of different shops in Bangkok, and I found a shop that specialized in connectors, and they had this one that is almost identical, hopefully identical or close enough that it will physically fit into the plastic connector. The issue is the motor controller that I was shipped had exactly the right number of these for the wires that go in and out of the controller. And as anybody who's tried to build a connector knows, some of these are going to get sacrificed to the gods. So you really need to ship extra pieces like this when you're selling a product. This probably costs 1/10 of a penny, and it's not worth it to your customers to not give them some extra spare parts. So I had to go off and find the one shop in Bangkok that had something close to this. Next up, we have Solder Flux. Solder Flux is very important when you're trying to make very, very good electrical connections between a piece of metal and another piece of metal. And I'm going to need this because I'm going to be soldering to every single battery cell in the pack. And I want to have extremely good contact. So they actually sell this kind of flux, which acts as a cleaner in a syringe. So you can very gently squirt a little dab of where you need to go onto your potential connection, then come in with the soldering iron and solder it up. So I figure it's good to stock up on a few of these. It even has an expiration date, which is almost ready to pass, the 1st of March. I'm only about 3 days away from the expiry on this, but I think I will tough it out and try and use it anyway. Okay, as I'm going to be using 18650 batteries in the pack, I need a way to be able to run certain tests on them, check them for capacity, discharge them, charge them, all kinds of things. So you need a holder for them, and this holder, if we can see in the reflection, maybe, is specially designed to be for, there we go, 18650 times 1. We can fit one 18650 battery in each of these holders, and I got 6, and that will match up with the next thing I'm going to show you, which I had to order by mail order, so I'm just going to jump ahead. But these are always good to have if you're building a battery testing station. And lastly, on the Bangkok trip, I have wire. I have 2 different gauges of wire here. I have 22 gauge and 24 gauge. Well, why am I going to need this? This is the wire that I'm going to use to connect each of the batteries to where the power needs to flow. I'm going to save that for an upcoming video. Just trust me on this. A lot of people who are building small e-bike packs, they use this kind of it's a flat nickel metal strip. Maybe it's very, very thin as a sheet of aluminum foil, and maybe 4 or 5 millimeters wide. They put up a set of batteries vertically, then they lay the nickel strip across, and then they spot weld the nickel strip to the batteries. For the idea that I have for my pack, it's not going to work that way because of the pack design, and I'll go into more detail on that later. But I'm actually going to use this wire as a fuse. Now, how do you do that? I've chosen these wire gauges, which are quite small. You can see 22 and 24 are very, very small. And what I'll do is I'll strip the insulation off. I'll solder to the battery, and then I'll solder to the board where it's going to connect. That little piece of wire can only handle maybe 5 or 6 or 7 amps of electricity flowing through it before it turns hot and vaporizes and breaks. That's exactly how fuses work. It's a piece of metal that heats up and breaks when too much current flows through it. You've got fuses everywhere. You've got fuses in your car, the little plastic ones. You've seen fuses all through your life. This is a wire fuse, and it's quite convenient for me because of the way my battery pack, the battery is going to be just like this through a hole in a circuit board, and then I'm going to solder the wire from the end of the battery to a spot on the board like that. Now, this is actually how Tesla solder or wires up the battery packs in their car. Every single 18650 cell in a Tesla is wired with small gauge wire. When a cell has a problem and starts either sucking in or pushing out too much power, the little fuse blows, takes the battery out of the circuit. You've taken away any risk of fire or overheating or cascading damage to the rest of the pack. And I have seen YouTube videos of people using this scenario for their packs also, in addition to that nickel strip type. So this is my plan, and we'll see how this works out. Okay, what have I got by mail order from China? Let's start in on those parts. The first one is pretty fun. It's this guy. This is a battery charger, discharger, and balancer. So what does all that mean? Well, rechargeable batteries need to be treated in the best way possible given the chemistry that they're built with. And you need a box like this that has the capacity to work with different types of batteries: lithium ion, lithium iron, nickel cadmium, nickel metal hydride, lead acid, and it's got good charge and discharge rates. And so you can set up some batteries and put them under charge. You can discharge them, you can charge them, and then you can have them all balanced to exactly the same voltage. And this thing's got the intelligence to do all that for you. So that's where those 18650 battery holders come into play, because this little box can manage 6 batteries at a time. So if I make a little platform and attach these 6 in a row, and then I wire these to the box, I can test and manage and charge and discharge 6 batteries at a time. Now I've got 320 batteries that are going into the pack, so that's really not optimal. But there's nothing on the market that I can find that has more than 6 or 8 batteries at a time. Wouldn't it be great if you could make something that could do 100 batteries or something for even 50 or 20? Like for a normal e-bike, takes probably 14 to 18 batteries for a normal battery pack. And the way that works is you use one of these, and I bought a whole box full of these things, this special connector with the wire, and the connector plugs in the side. It can take 2, 3, 4, 5, and 6 cell packs at a time and do its magic. So I would wire up the 6 packs or the 6 cells into this thing and then let it do its thing. Now, this unit comes with a number of different kinds of connectors, and these are all designed for the radio-controlled battery industry, like for people with radio-controlled cars or radio-controlled boats or planes. And the way it works is you plug in the side with these banana plugs. That goes there and that goes there. Then you use whichever kind of connector you need, and you just mate that up, and now you've got 2 alligator clips, or you've got this kind of phone plug, or you've got this special connector, or you've got this special connector, or and this one's actually for powering it. It needs power to run. So this will be my battery testing station. I'll just 3D print a platform, stick those on and wire them all up. And then we'll be playing with batteries. Now to follow up with this connector, we have these. And we have these because every single battery in the battery pack is going to be wired up to one of these connectors. And the reason I'm doing this is twofold. One, so I can periodically plug a device in that measures the state of every battery in the battery pack. And if there's a battery that's a little high or a little low, but still in good shape, I can plug that little blue box in and balance this little subset of cells within a pack in place without taking the whole pack apart, which is going to be nearly impossible once it's all together. So I need this many of these connectors to make that happen. And the little guy that does the checking for me is this little box here. You have to give it 5 volts from a USB connector, but it also can do data logging and stuff too. But say that's in the pack, I come along and I go from pin 1 and I just plug it in like gently like that. And then I push the buttons and it tells me about all my voltages, and I can just go march my way down the connectors in the battery pack and use this device to make sure everything's okay. This can take up to 8 batteries, but like I showed you, the blue box can only do 6. So I'm designing the battery pack for modules of 6, and then I will just voltage test 6 at a time with this little guy. Okay, you may be asking yourself, how do I isolate 6 batteries at a time that's in a 20 cell battery pack? Because if you don't isolate them, it's going to have an effect from all the other batteries that are in that module. So here we have the solution. This little button will enable the module or the submodule of those 6 cells to be either in or out of the pack. If this is in the up position, they're isolated, and I can do the voltage checking, and then I can do charging, discharging, and balance. If I push it in, then it's in the circuit and I drive away on the motorbike. So I need this many. And the cool thing is these are circuit board mounted switches, and they'll be mounted vertically on the side of the circuit board in the pack. So if we think of this as the circuit board, the batteries are going to be like this and soldered onto the traces of the circuit board. The switch will be like this, and I'll be able to reach it from above and connect it to the pack or isolate it. And then those little 6-pin connectors will be also along here, and I can attach the voltage measuring and the balancer to that. So this is the key for isolating the modules. Okay, you saw that I'm doing battery cell level fusing with the fuse wire, but I'm also doing battery module fusing with this. Now each of the 20 battery modules will be wired up. You cut this and then you put it in the circuit, but each of them will take an automotive fuse which goes in here, and then you seal it up for weather protection. And this will add an additional level of fusing for the entire 20 cell module, and this will give it additional module level fusing on top of the cell level fusing with the fuse wires. So if I ever do anything, I take the chance to over-engineer it, so that's what I'm doing. So there will be 20 of these, and here they are. Now, one of the things I needed to get was a way to have power coming into the bike from the charger, or to feed the new charger that I showed you on the previous video. So I went and I ordered the smallest pack I could find of these flip-top connectors that you can put a computer cable into. So what happens is I will run these wires straight into the new charger, and it will be an AC wire input straight out of the wall. The charger that's in the bike now, it also has a connector almost exactly like this, but it's the output of the charger that goes in here, and the charger is changing it to 60 volts DC. So on the bike, I'm going to have a 60 volt DC input and a 230 volt AC input. So I'm going to install them in different parts of the bike and label them, because I do not want to have the chance to plug the wrong wire into the wrong thing, because that will ruin your whole day. And last but not least is something I can't show you. I ordered 340 18650 cells from Alibaba.com, and I sent them the money on January 26th, and this is after a week of back and forth with the sales lady. I'm not going to blame it on language, because her English was excellent, and I thank her for that. But it was so confusing, because when I placed my initial request, I gave a link on Alibaba to exactly the battery cell that I wanted, which is an NCR 18650B cell made by Panasonic, which is the same company that makes batteries for Tesla. Yay, Tesla. But I specifically requested what's called the protection circuit. And this is adding yet another layer of protection to the battery. It's a tiny little circuit board that is mounted to either the bottom or the top of the battery, and then shrink wrap is put over everything. So it just looks to be like a fully made battery cell. The purpose of this circuit board is to protect the battery from overcharging, undercharging, too much current, too low voltage, too high voltage. Everything you want protected by an 18650 battery, this thing is supposed to protect it. And she went on and on with questions about things that she should understand. And I was saying, I want to buy this part, and I would give her the exact link. And then she would ask me questions about her own battery that she was selling on Alibaba. In the end, I made myself clear, and we agreed on the price. And I did a telegraphic transfer of the money on January 26th. Today is February 27th. And in the middle of all this was Chinese New Year, when the China world shuts down and doesn't do nothing. Now, great. But what she failed to inform me when I placed the order was they have to go and order the little protection circuit board from another vendor. Then in their factory, they mount it into every single one of the battery cells that I have ordered from her. Now, my question is, why is she offering for sale on Alibaba a battery cell that she doesn't have in stock and has to manufacture using parts that she doesn't have in stock and has to buy from another vendor? And look, my money is already in her hands at this point. Now, we're coming out of Chinese New Year now, and I just sent her another message on the Alibaba message service asking her for an update to the batteries. I'm guessing I'm not going to see them until April, because if she has to wait to the end of Chinese New Year as it drags out, and it's not just the 3 days, the businesses have go away for weeks on this sometimes. She's got to get the parts in her factory and manufacture them and then ship them to me. I'm not going to see them until April. And this is very troubling. But it's what you get when you deal with companies from China, and you're kind of at their mercy. I mean, there's no place that I can walk up and buy a giant box of batteries in this country. You have literally no other choice. So the batteries will wait. And as you can see with the pictures that I posted, you can see what I'm looking at. So fingers crossed that the batteries come soon, and then we can actually get to work building the battery pack and playing with batteries. So that'll wrap it up for today. Keep your fingers crossed for me. Check in with you next time.